Boom, boom, boom.
Maybe I should turn this off. Oh. Nobody's watching anyway. So why would I? Oh, hi, Simon. I'm good. Well, just trying to figure this out. I just discovered it has been over 2 months since I've live streamed, but yeah. I remembered that they actually they do this live earlier, so I thought, well, why not just go ahead and put it on live, and then 1.5, so in an hour and 15 minutes, I'll go live, like real life, but yeah, this is good enough for now.
And MES1 LC on countdown 1.
LC MES1.
Yeah, MES1, let's go ahead and run through step 313, our required to non-requireds for today's operation.
LC, step 385 will be not required. Step 387 will be required. Step 388 will be required. Step 389 is TBD. Step 397 is required. Step 405 is required.
Copy all there, MES1. We'll go ahead and check step 313 complete. And GSO-LC countdown 1.
GSO.
Yeah, GSO. I'll wait for your call on 315 when you can confirm you've got your pad clear zone established.
Copy. I'm just waiting on Red Team to report in at V50, and then I can make that report.
Okay, excellent. Thanks, GSO. Okay, launch team LC on countdown 1. We're going to go ahead and proceed into our final updated weather briefing for today's operation. So, Elwell, you go for step 314.
This is Elwell on countdown 1 with the updated weather briefing. We are seeing mostly clear skies out there, chilly conditions. Temperature has dropped into the upper 30s here at Wallops overnight, and we are starting to see that temperature creep up a couple of degrees, up to about 40 degrees right now on the island. And we will continue to see chilly conditions as we go through the count into our launch window, where we'll see very nice conditions for launch. Really no big changes from our previous weather briefing earlier in the count. We're seeing our upper level wind data pretty much the same. Our latest balloon showing that max wind at 40,000 feet at around 92 knots. 40,000 foot level forecasted to be just a couple ticks higher at around 99 knots for our max wind throughout the entire profile, but very similar wind conditions aloft for the expected T-minus 0 compared to what we have now with our latest balloon. Taking a quick look at our radar, you can see nothing to be seen as far as radar returns in our general vicinity of Wallops, and we are expecting those dry conditions to continue. Infrared satellites showing mostly clear skies, and that is also expected to continue through the countdown as we approach T-minus 0. So launch forecast for us, just a few clouds expected at 2,000 feet. They will be off the coast, maybe a few clouds at 25,000 feet with the upper level cirrus. Unrestricted visibilities. Our winds will be fairly light at T-minus 0, expecting 5 knots. It will be variable anywhere from a northwesterly direction to a easterly direction, expecting it to kind of stay between those azimuths. Temperature at 45 to 48 degrees, relative humidity between 65 and 75%. And as you can see, we're expecting a green chart as far as any kind of weather constraints being violated. Not expecting any at all at T-minus 0, so 0% total probability of violating any weather constraints. We are good for weather going forward. Any questions?
All right, Elwell. I appreciate that good report for today's op, and we'll go ahead and consider step 314 closed at this time.
LC, Red Team Lead, Countdown 1.
Go ahead, Red Team Lead.
Yes, sir. Be advised, Red Team has fallen back to V50.
Copy that, Red Team Lead. Thanks for the heads up. We'll check 312 complete.
LCGSO 315 complete. Pad clear zone established.
Roger that, GSO. Thanks for the heads up. We'll go ahead and check 315 complete. And Launch Team LC on Countdown 1. We've established our final pad clear zone for today. Our Red Team has evacuated back to building Victor 50. We've received a good weather update for the remainder of today's operation, and we'll be looking to perform our start for propellant loading operations poll at L-1 hour and 23 minutes, and that'll be in just about 1 hour 23 minutes. That'll be just about 8 minutes here. And everybody should be advised in step 316, our target CDT resumption time is going to be 123947 Zulu. That's 123947 Zulu. Check 316. Okay, Launch Team LC on countdown 1. At this time, I want to proceed with step 317. This is our poll for readiness to begin propellant loading operations. Mars site?
Mars site is go.
GSO?
GSO, go.
RSO? RSO? Yeah, RSO step 317, poll to begin final propellant loading operations.
Yeah, RSO's go.
TD?
TD is go.
CMD?
CMD is go.
Safety?
Safety's go.
Prop lead?
Prop lead is go.
Stage 1?
Stage 1 is go.
GCE?
GC is go.
ACE? LD?
LD is go.
We're go to begin propellant loading operations at T-minus 1 hour, 20 minutes. Check step 317. That completes our Lowell's chill down checklist. We'll be kicking off with our propellant loading operations checklist, step 318, in just about 2 minutes. And TLM LC, countdown 1.
Go ahead, LC.
Yeah, let's go ahead and kick off 319 at the TCOM, stop and restart telemetry archiving.
Copy that, in work. And archiving restarted.
Copy. Till then, we'll check 319 complete. And launch team, our countdown has resumed. Site control, you go for step 320 and 321. Arm and start the RP1 tank desiccant hose retract. Verify when retract complete. Arm and start L2 tank desiccant hose retract, and verify and retract when complete.
Copy that, in work. And RP tank desiccant hose retract started. And it's now visually confirmed. RP1 retract confirmed. And LO2 tank desiccant hose retract started. And LC, this is site control. I do not have visual confirmation.
Okay, copy site control. Prop lead LC, countdown 1.
Go ahead,
Excuse me, GCE LC, countdown 1.
Yeah, GC on countdown 1.
Yeah, you understand we do not have visual on the LO2 retract?
Yep, I got the camera and I see that we got some tension in the strap, but it did not pull the head from the vehicle.
Okay, any recommendations?
Yeah, can we take this to an anomaly panel for discussion?
We're about to start LO2 loading. I don't think we have the time.
Yeah, my recommendation is we pull the tail, and as the tail moves, it'll pull the desiccant head out of the vehicle attachment.
ACE LC countdown 1.
Yeah, I think we can support that.
Okay, roger that. Site control, we're going to go ahead to step 327, command tell to pre-pullback position.
Copy that. Sending to pre-pullback position.
And we have confirmation of desiccant head retract from vehicle.
Copy that. Site control, step 323, re-verify ECS air dew points.
Stand by. Okay, and the LO2 retract is confirmed.
Yeah, I'm looking for step 323, re-verify ECS air dew points.
Yep. And the ECU 1 is negative 49.3, and the ECU 2 is negative 49.5.
Roger that. GC, step 324, verify heated GN2 pressure and temperature.
And I can give you a verification there, LC.
Okay, roger that. 324 is complete. Heated GN2 parameters are nominal. And launch team, start a core low flow RP loading and low flow LO2 chill down will occur at T-minus 1 hour and 16 minutes. That'll be in just over 30 seconds.
LCTD on countdown 1.
Go ahead, TD.
Yeah, be advised that the Mach and RCC fire alarms are now disabled. Please refer to the Antares alarm contingency plan.
Okay, roger that. And lead LC, countdown 1.
Go ahead, LC.
Yeah, looking for step 325 from you.
Yeah, stand by, LC. LC, this is prop lead. I can confirm the start of low flow RP loading and start of LO2 vehicle chill down.
Copy that, lead. We'll check step 325 complete.
LC tell.
Go, tell.
Yeah, I can confirm pre-pullback, step 328.
Roger that, tell. We'll check 328 complete, and everybody should be aware of the fact that we've already performed step 327. That's complete as well.
And LC, this is prop 3. The start of high flow RP loading has started.
Copy that, prop lead. We'll go ahead and check step 326 complete. Okay, launch team LC on countdown with the status here. We've gone ahead and started our core low flow RP loading and our low flow LO2 chill down. Our next phase will be to start our core high flow LO2 chill down, and that's expected just about 5 minutes.
LC prop lead on countdown 1.
Go ahead, lead.
High flow LO2 chill down has started.
Copy that, prop lead. We'll check step 329 complete. And launch team, at this time I want to get a readiness statement for accumulator refill. GC?
GC is ready for refill.
EHS?
EHS is go.
Ops 1?
Ops 1 is go.
Prop 2?
Prop 2 is go.
Prop lead?
Prop lead is go.
Okay, launch team, we're going to go ahead and press into our accumulator refill. Prop lead, you're ready to, or you're go to start Appendix Alpha Romeo, and you can perform that on Anomaly 3.
Copy, LC. prop lead on countdown 1. HSS accumulator refill procedure complete.
Copy that, prop lead. We'll check step 331 complete. And launch team, be advised, we're going to go ahead and delay our selection of our trajectory file today until about T-minus 45 minutes or so, and then we'll go ahead and upload at that time. Our next event will be start of core low-flow LO2 loading, and we're expecting that in a couple minutes here.
LC, this is prop lead on countdown 1. Low flow LO2 loading has started.
Copy that, lead. We'll go ahead and check step 336 complete.
LC, prop lead. High flow LO2 loading has started.
Copy that, lead. We'll go ahead and check step 337 complete. Ops 1 LC on countdown step 338. Can you verify work nav settings?
Standby 1.
Standing by.
LC Ops 1, orb nav settings verified.
And I copy that, Ops 1. Step 339, you go to initialize nav position.
Orb nav position sent.
And GNC1, I'll wait for your call on step 340.
LC GNC1 orb nav telemetry verified.
Copy that, GNC1. And launch team looking for a readiness statement for GC Align. GNC1?
GNC1 is go.
Ops 1.
Ops 1 is go.
Elect 1?
Elect 1 is go.
We're ready for GC Align. Check step 341. And Ops 1, step 342, mode orb nav to GC Align.
And work. GC line sent. iRig is 130800.
Copy that, Ops 1. And launch team, it'll take about 5 minutes after our gyro compass alignment to verify all of our orb nav telemetry, and we'll wait for that to get a call back from GNC1 for verification. Our next loading event will occur at approximately T-minus 43 to 44 minutes, and this will be a confirmation of submerged, that our cold helium bottles are submerged.
Go MES1.
And GNC1LC, countdown 1.
This is GNC1.
Yeah, GNC1, I'd like to go ahead and kick off step 332 if you can provide the flight computer trajectory file for today's op.
LC, this is GNC1. Trajectory 3 is selected for today's operation.
Okay, copy that. And Ops1LC, countdown 1.
Ops 1 on countdown 1.
Yeah, you go for step 333, and we're looking to select flight computer trajectory file number 3.
Copy that. Trajectory 3 selected. Successful.
And GNC1, I'll wait for your verification in 334.
LC, GNC1, trajectory file verified in telemetry.
Roger that, GNC1. Ops1, verify ground to vehicle comm is nominal.
Ground to vehicle comm is nominal.
Okay, we're going to go ahead and check steps 332, 333, 334, and 335.
LC, this is GNC1 on countdown.
Go ahead, GNC1.
OrbNav GCL line telemetry is fully verified.
Copy that, GNC1. We'll go ahead and check step 343 complete.
LC, this is prop lead on countdown 1. I can confirm cold helium bottles are submerged.
Copy lead. We'll check step 344 complete.
LC2D on countdown 1.
Go ahead. Go ahead, TD.
Yes, range remains green for toxic and debris.
Copy. Good call. Or thanks for the heads up there, TD.
LC prop lead. Cold helium bottle charging has started.
Copy that, lead. We'll go ahead and check step 345 complete.
Oops! Okay, that went wrong. Ish. I almost shut down my computer. Anyway, am I... Yeah, I'm listening to myself, so you can hear me. But now... I need to find... Okay. Yeah, this is the good stuff. Okay. I need to find... Okay. Yeah, this is the good stuff. Okay. I need to find just one more app. Okay. Yeah, this is the good stuff. Okay. I need to find just one more app. Yeah, this is the good stuff. Okay. I need to find just one more app. Yeah, this is the good stuff. Okay. I need to find just one more app. Yeah, this... Okay. I had to break that loop.
Okay, launch team LC on countdown 1. I want to go ahead and proceed with step 348 at this time. Ops 1, you go to enable your local launch enable button at the failsafe panel and verify local indicator is illuminated.
Launch enabled and illuminated.
And GSO, you go to enable your local launch enable button.
This is GSO, launch enabled and illuminated.
Copy that. We'll check 348, 349. And I want to verify the RCC enable aboard buttons are enabled and illuminated. PM?
PM enabled and illuminated.
RSO?
RSO enabled and illuminated.
FSO?
FSO enabled and illuminated.
TD?
TD enabled and illuminated.
Step 350 complete. Ops 1, Ops 1, I'll wait for your call on 351.
Master global launch enabled verified.
Interlock 1 confirms in telemetry.
Roger that. We'll check 351 and 352. And Ops 1, step 353, you can stop sending ECU commands.
ECU commands halted.
Copy all. We'll go ahead and check 353 complete.
Okay, let's go. 42 minutes out. Let's mute this. And let's go to here. Hey! Hi, everybody. Okay, now I need to pull up the stream again. Okay, today, Antares. Antares 230 plus. So Simon already asked the question, what does 200 plus mean? Well, the 200 plus is the upgraded version of the Antares. Let me close my door first. Yeah. So the you can see the H2 launch pad that I built hanging out somewhere like right there behind my bed. Anyway. Yeah, the lighting is a bit iffy. I don't think this will change much though. But yeah, you can see me. That is what counts. So yeah, the Antares. Oh wait, I still have the model up here. Right, it's the interstage. Second stage. Hold on. Second stage? Where did the interstage go? I seem to have lost the interstage with my Antares. Oh no, it's over here. Okay, so yeah, the 230 plus version. Normally you would see it, Antares 200, which means the they have the extended second the fairing, and then the Castor 30 XL second stage. That is what the 30 stands for. The 2 stands for the oh yeah, that was it. Normally before the big Antares explosion, they used the AJ26 engine. Yeah, yeah, the AJ-26, which was, well, it was used, a version of it was used on the N1 rocket. So yeah, what happened with that is the one of the turbo pumps exploded actually. I believe that was because of a bolt got sucked into the turbo housing and then it blew up. So I can't talk and do this. I'm not a woman. I can't multitask. Well, yeah, it was basically an NK-33 with some parts taken out, and that was the 1 version. So you have 3 digits, and so the first digit is a 1, a 2, or a 2. The 1 was used with the NK-33, and right now they use RD-80s, if I'm correct. No, RD... The RD-180 is on the Atlas V, so they use a 91, right? RD-91. And anyway, it's again a used a Russian used engine. I thought it burned through a fuel line. No, I'm pretty sure the turbo housing. There was either a when you have the impeller of the turbo pump, so you have the turbo part on top, and then where the gas comes through the turbine part, I believe, or one of the blades of the turbine blew up or like fell off, but it had to do with the turbine part of the turbo pump that blew up. So yeah, but then again, the second digit can be a 1, a 2, or a 3. Again, I don't know what the 1 and 2 stand for, but the 3 are Castor 30 XL, and the second one, so if it's a 2, I believe it was a Castor 30 just regular, and then the Castor 3A was, I believe, the 1. And then we have the 0 that is for the third stage, because the Antares can be configured in a 3-stage, as a 3-stage rocket, but right now they're using a 2-stage version, so you can see a 1 or a 0, a 2, or a 5, I believe. And that is either a hydrazine fueled third stage or something else. Another solid rocket booster. But right now the plus indicates that the first stage, so this part, is right now the top part is still the same. Only the only difference is that right now the fairing has a top hatch, which allows for late loading of the cargo. So just before it went vertical, they loaded the cargo in, so the most time critical cargo. But the first stage is what it's all about today, because the engines, normally the rocket is so light and the engines are so powerful that they are under throttled, which reduces the performance of the engines, but you also lose efficiency through that. So right now what they're doing, what they did actually, is the structure of the first stage has been made stronger, so it can handle the load of the engines. So the engines have a bit more thrust right now, and I believe they can even carry a bit more fuel now and let the stage burn for a bit longer, because before this the stage was actually set on a time, so speed, certain speed, because the solid rocket booster on top, because this uses liquid fuel, it's a liquid fueled stage, so liquid oxygen and RP1. Yeah, liquid oxygen RP1. So the kerosene. And then so that's your second question, Simon. It uses solids and liquid oxygen, and RP1, so liquid kerosene. but the speed was set at a certain amount, so they had still performance left in the first stage when they shut the engines down, and so that is because the second stage can't be throttled. It can't be throttled. It can't be shut down. So they can't really overshoot the target orbit, because that would allow. Well, that would mean that the Cygnus would need to make a lot of extra maneuvers, so they don't want that because it's all planned out in advance. And so what they have to do is they have to aim for certain apoapses, and once they hit that, they have a certain speed requirement in direction. So they shut that down as soon as it hits so they shut down the first stage as soon as it hits the threshold. But afterwards, so post-flight analysis, actually showed in last launches that they had a little bit more performance. So each flight they increased the payload weight of the Cygnus a bit, so to counteract the left performance. But right now they can unlock even more performance of the Antares, because they don't need to actually throttle down as much, and maybe they can even run it as dry as possible. I don't know exactly if that is the case today, but in future flights this allows them to basically get that more tiny bit of performance out of the engines, actually. Because the further step would be just having the full throttle first stage engine. So instead of the under throttled, just put them on full throttle. But they would probably need to stretch the first stage to have more fuel, because otherwise they would just have too little weight, so the rocket will go up like a Vega, and it will keep burning. It will keep gaining G's of acceleration, which you don't want, because I believe the payloads, it is probably stuff that goes to the ISS is probably somewhere around 4 G's maximum, 4 G's, 4.5, because some experiments are living experiments, so they need to take care of that. So they can't just go 6 G's acceleration. So yeah, funny way of going about it. Yeah, but that is because they have the second stage that is solid, so they need to shut down the first stage early, otherwise you will definitely overshoot your orbit. And I will switch to... Let me switch. Let's go. I need this.
LC Ops 1, TVC and EHA buses enabled.
Switch.
Roger, Ops 1. Site control, step 372, arm tel for rapid retract.
Okay.
And in work.
Let me know if I need to turn the volume down or up, or if it's okay. These images are way better. So, it's perfect. Okay. And then there's another case of on which the Antares stands out. That is, it throws away its first stage before it throws away its fairing. The only rocket that does that is besides the Antares, is the it's the Atlas V. The Atlas V for XX configurations throws away its fairing after stage operation 2, but most of the times, and the Falcon 9, it's not that special. Why do I think this is special? Well, because it's a sort of weird way, because it throws away the first stage, and then just coasts with for a few seconds with the fairing and.
This morning, we are joined by Christina Halona, Program Manager for Antares Systems, Engineering, Integration, and Test, here with us from Northrop Grumman today. Thanks for joining us.
Thank you for having me. I'm excited to be here, and good morning to everyone who's joined us this morning.
So can you tell us a little bit more about your role?
Sure. As the Antares Systems Engineering and Integration Test Engineer, Program Manager, my role is to provide systems engineering leadership to efficiently and reliably execute Antares' cargo resupply mission to the International Space Station. My team and I work to increase the focus on clear requirements development, interface design, testability, and verification. The system engineering is an important role to Antares as we actually get to, interface with all the different engineering disciplines through across the program. And we do this to ensure that we are always in compliance with our customers' requirements and their needs throughout the program.
That's great. So there are some differences with this launch that we saw this before on Northrop Grumman 11, but we're seeing it again on Northrop Grumman 12, the late load option for cargo on Cygnus. Can you tell us a little bit more about that?
Sure. One of the unique features of the Antares 230 Plus vehicle is that we have built new specialized ground support equipment that allows us to take the vehicle from vertical to horizontal. This allows us to kind of drive what we call a mobile clean room right up to the pad, as you see that there in the graphic. And this allows us to remove the pop-top fairing. We can't see it there in the picture, but there's actually a pop-top on top of the fairing that comes off. And we're able to load time-sensitive research experiments and other perishable items that NASA needs to provide 24 hours prior to launch. I'd also like to note a key flexibility feature added to the CRS-2, which is the ability for NASA to significantly alter the final cargo load by up to 20% as late as the 24 hours before liftoff. And you can't see it here too, but there's a bladder that inflates between that little opening there and the fairing, and that inflates to close the gap between the clean room and wall so that everything that goes in and out is protected.
It's very interesting, and I understand this is not the only difference for this flight. This is the first flight of the Antares 230 Plus rocket. So what are some of the differences between 230, which we've seen fly before, and 230 Plus?
Sure. So the NG-12 is the first flight of the Antares 230 Plus configuration. And the difference from Antares 230 are the upgrades to the Stage 1 core. It's also lighter composite structures and an optimized second stage mortar. The upgraded Stage 1 core allows Antares engines to perform at full thrust throughout most of the first stage profile. With these upgrades, we're able to offer NASA more cargo capability for their CRS-2 missions by increasing the performance of Antares. We're also providing more flexibility for the final cargo load as well. And this figure everyone can see is the differences, and you can see in comparison how much we've kind of taken off, and there's definitely lots of mass savings for us for 230 Plus.
Great, more efficient and able to deliver more cargo, so that's what everyone wants.
Oh yes, and that we'll be doing that for 230 Plus going forward.
Thank you so much, Christina. We are now just over 17 minutes from launch of Cygnus. We'll be looking for that at 8:59 a.m. Central and 47 seconds, 9:59 a.m. Eastern and 47 seconds. But the teams have been progressing smoothly throughout the morning through some pre-launch milestones. That began about 4 hours ago with poll for readiness for the launch vehicle to be powered on. And then an hour and 20 minutes before launch, fueling began of the first stage. That's liquid oxygen and R21 kerosene.
Roger that. System will check 379 complete.
There have been various checks throughout the morning between Houston and Dulles, Virginia, to ensure everything is on schedule. And at the 12-minute mark before launch, we will have a poll to proceed with the final countdown. Everything continues to proceed smoothly, and at 5 minutes before launch, the vehicle will switch to internal power.
Lead on countdown 1.
Go ahead, lead.
F1 N level is 13 of 13.
Roger that. Lead Core 1 LC, countdown 1.
About 3 minutes and 30 seconds before launch, auto sequence handoff for terminal countdown will be initiated, and that marks the time the computers take over for the final steps up through the launch at T-0.
Launch team, be advised, Step 385 will be not required for today's operation. We'll be coming up with our poll to proceed with final countdown in just about 3 minutes.
Okay, go, no, go poll in 3 minutes.
And Core 1 LC, countdown 1.
You probably will be able to track it all the way to
LC, this is Core 1 on countdown 1.
All Cygnus vehicles are named after people who have made significant contributions to spaceflight but have passed away, and this vehicle is named after the late Apollo and Skylab astronaut who died on May 26, 2018 at the age of 86. That's Alan Bean. It's very appropriate that Cygnus is named after Bean on this mission. It launches 50 years to the month after Alan Bean, Pete Conrad, and Dick Gordon flew to the moon on the Apollo 12 mission, in which Bean became the fourth human to walk on the lunar surface. He was the lunar module pilot aboard Intrepid with Mission Commander Conrad when they landed on the moon at the Ocean of Storms on November 19, 1969. 4 years later, he commanded the second crewed Skylab mission, Skylab 3, which launched on July 28, 1973. Bean, Owen Garriott, and Jack Lousma spent 59 days in space aboard America's first space station. That's Alan Bean, and we will see the Cygnus named after him flying very shortly today.
Roger that. Prop 2 will check Step 382 complete.
Nice weather. No clouds, so they will be able to see it probably till the first stage shutdown. I don't know if they're going to be able to see the second stage burn. But yeah, you're going to get some cool images. And located, I haven't actually tried and watched, but
CMD-LC, countdown 1.
The second Rocket Lab launch pad is located just next to the Antares.
And CMD-LC, countdown 1.
CMD, countdown 1, go ahead.
Yeah, CMD, looking for status on your internal power?
Yes, Cygnus is on internal power and nominal.
Roger that. We'll check 384 complete.
So the rocket is already on internal power. And the payload will, but they talked about going internal 5 minutes before launch. Now I'm confused.
And launch team LC on countdown 1. At this time, I'm going to poll to proceed with final countdown. GSO?
GSO, go.
RSO?
RSO's go.
TD?
TD is go.
Prop lead?
Prop lead is go.
Stage 1?
Stage 1 is go.
MES1?
MES1 is go.
GC?
GCE go.
ACE?
ACE is go.
Mars?
Mars is go.
CMD?
CMD is go.
LD?
LD is go.
NG?
No,
in honor of Alan Bean, who shared the gift of exploration in both life and art, and inspired future generations to travel back to the moon and beyond, Northrup Grumman is go.
Copy. And we are go to proceed with final countdown.
I see the rocket lab pad. If you look, if you follow the tower downwards, there's like this long structure going out, and just in front of the end of the flame trench of the Antares, you can see like a black spike. That is the Rocket Lab Electron second launch pad. But according to my timeline, indeed, only the Cygnus should be on internal power. Well, they might go onto internal power at the same time, but yeah.
And Ops 2, LC, countdown 1, step 387. Go to start engine evacuation.
Engine evacuation started.
So engine evacuation means that they are purging.
You just heard the poll to proceed with the final countdown, and we're also watching some ducting happening off the rocket. We can't really see the Antares logo so well anymore. So Christina, can you tell us a little bit about what's happening there?
Sure, you can see the top half of the first stage of the vehicle is really cold with that cryogenic liquid oxygen. The Antares logo is almost completely obscured by ice, as you can see there. The evaporative process is happening, so the liquid oxygen is blowing off of its relief valves. That is super cool.
She whispered, that is super cool. That's fun. Yeah, are there any changes we can see? Yeah, it's so funny. She whispered,
just under 10 minutes until launch of Antares, things continuing to proceed smoothly throughout the countdown this morning. Once we get to the launch, the first thing that will occur is the stage 1 ignition. You'll see liftoff just a few short seconds afterward, and those main 2 engines will burn for about 3 minutes and 18 seconds before cutting off, and stage 1 will separate from the rest of Antares. Cygnus will coast for a bit until fairing separation, when the external cover that protects the spacecraft during launch will separate. The interstage adapter that connects the first and second stages will separate at 3 minutes and 58 seconds into flight before stage 2 ignition, a solid rocket fuel that will burn for 2 minutes and 43 seconds. Once the second stage burns out, we'll be listening for the call of orbit insertion for the rocket at 6 minutes and 49 seconds after launch. The vehicle will coast for 2 minutes before Cygnus separation, 8 minutes and 49 seconds after liftoff, with solar array deploy occurring about 2 hours and 53 minutes after launch. The deployment of those 2 Ultraflex solar arrays currently tucked away on Cygnus takes about 30 minutes, and then the vehicle will begin gathering power for the next couple of days during its journey to the space station.
We haven't showed the wall.
They forgot to turn their mics off. It's so cool. It's quite funny. They're really looking forward to it. Oh, and you can see behind there, you can see the NG-11 logo still hanging there. That is because the NG-11 hasn't re-entered yet. It's still in orbit, because that is part of what they're showing. They're trying to show that they can handle 2 at a time. That is probably the engine purge. So what they do is normally the engines are pre-cooled with either the liquid oxygen or the RP1. I don't know what is the case with this engine. I believe it's the RP1, but it's a Russian engine, so it could also be liquid oxygen. Need to change volume? Okay.
And Ops 2LC, countdown 1 step.
Okay, so it's right now it's also venting probably from the liquid oxygen. That is vented out of the fuel lines to prevent a like mini explosion or a fire after launch. But the engines are purged because there are fumes of either the RP1 or liquid oxygen hanging around there. And if you don't purge the engines, you probably will get a hard start, which is that the fumes ignite inside of the whole engine before you actually produce any flow, so it's hard to describe this, but normally you would start your fuel and oxygen to flow, and then just as they get out of the oh no, it's silent again. I'll turn it up again.
Transfer to GN2 confirmed.
So
5 minutes and 45 seconds until the launch, and the next milestone for Antares will be for the vehicle to begin turning on to internal power at 5 minutes.
So the Antares indeed turns to internal power at 5 minutes. Okay, well, weird. Anyway, you normally ignite the fuels just after they come out of the injector, but if your whole engine is filled with fuel, the pressure, or actually the flame, you get a sort of pressure spike because the whole engine is a combustion chamber.
For today's operations. And Ops 2, you go to initiate engine priming at T-minus 5 minutes.
Engine priming started.
Ops 1, you go for step 398, transfer avionics to internal power.
All internal power on selected.
So it was probably
completion.
Only the rocket
all
itself,
external
so
power
systems on internal power, and now avionics is on internal power.
And LC Elec 1 confirms internal power is nominal.
Ops 1, step 400, open FTS umbi loop and verify green indication.
FTS umbi loop open and green.
LC Elec 2, FTLU, and FTS receiver indications are nominal.
This hasn't been mentioned,
step 402,
but
send all armed command.
LC Ops 1, all armed command.
Instantaneous launch window, so any problems will result in a
LC Elec 1 confirms SNAs and ODMs all armed.
And 24-hour reset.
NASA TD, report range status.
LC TD, range is green.
Copy, range green.
LC MES 1, step 405, priming verified.
Copy, priming verified, check 405 complete.
Three minutes and 30 seconds until launch. Everything continuing to proceed nominally for Antares.
Be advised, phase 3 dynamic limits will be active at T-minus 3 minutes.
FC command into flight mode. Auto sequence start.
Yes, we're in the auto sequence.
ODM bus voltages and currents nominal.
Copy all LEC 1. GNC 1, step 411, verify ready for nav mode.
LC GNC 1, ready for nav.
And Ops 2, step 412, switch to nav.
LC Ops 2, switch to navigate.
LC GNC 1, orb nav telemetry verified.
Copy that, GNC 1, check step 413 complete.
Let's go. 2 minutes.
And we'll be at T-minus 2 minutes. Mark.
So the ones that are wanting to switch, my live stream is just 6 seconds behind, so it doesn't really do much to switch.
1 minute and 45 seconds until launch. Everything proceeding smoothly for Antares and Cygnus.
Hi, Profenes. Welcome.
Still
Just
looking at an on-time launch at the opening of a 5-minute window. Aiming for launch at 8:59 a.m. Central, 9:59 a.m. Eastern.
1 minute, 30 seconds.
So indeed that black spike is the Rocket Lab launch pad. It's really close. There we go.
T-minus 1 minute.
1 minute.
Mark.
$50 seconds. There we go. 45.
Range is green, weather is good. 40 seconds
40.
until launch.
35.
T-minus 30 seconds. Mark.
25. 20. 19. 18.
20 seconds until liftoff.
16. 15. 14. 13. 12.
T-minus 10.
10. 9. 8. 7. 6. 5.
5. 4. 3. 2.
1. Ignition. Liftoff, yes.
Liftoff of Antares. NG-12 mission. All facility. Engines at 100%. Attitude nominal. Power nominal. Engine performance nominal. Attitude nominal. Or pressure nominal.
Everything nominal. This rocket is phenomenal.
Power nominal. TBC performance nominal.
Nominal. We should cut out all the nominals again and put them in a row. See how many we get to.
Estimated alpha, 1 degree.
Woo!
BNO3 is open.
Looking good.
Engines remain at 100% and steady. Beginning of load relief. Power is nominal. Estimated alpha 1 degree. Engines remain at 100% and steady.
Good.
Power is nominal.
There you go.
Load relief, phasing out. The NG3 is open.
Yeah. That looks phenomenal.
Roughly 100 seconds to MECO.
Everything proceeding smoothly, about 100 seconds till main engine cutoff.
Just passing 100,000 feet. 100 feet per second squared. High altitude pitch up at 5 degrees.
Yep. They're now pushing the apoapsis out to the point they want it to.
Enabling velocity steering. Engines remain stable.
It looks good.
1 minute to MECO.
Straight. Not a lot of corrections.
Engines remain at 100%. Attitude is nominal. BNO4 and BNO5 activated.
So yeah, let's go.
Power nominal.
Let's do this. Go to orbit.
Just passing 200,000 feet. Slow throttle down to 80% initiated.
So G limiting.
Main engine cutoff coming up in about 15 seconds.
Use metric, yeah. Well.
Engines 55%.
55. Ooh, that's pretty hefty.
Engines remain nominal.
This is where they lose the performance.
Main engine cutoff, nominal. PSS disabled. Stage 1 separation.
Yes. Wait for it.
ACS enabled.
So that's the reaction control system?
Attitude nominal.
You can see in this graphic, Cygnus is separated from the stage 1, and in the next few seconds, we'll be looking for the fairing separation. That's the shroud that covers and protects Cygnus during its launch.
So as you can see, the
Stage 1 ignition time projected at T plus 245.
T plus 245.
fairing separation.
Interstage separation.
Interstage separation.
Yep. That's what I said. There we go, ignition.
Stage 2 ignition.
I was talking about
Stage 2 is that solid rocket fuel that will burn for about 2 minutes and 43 seconds.
Nice.
Attitude nominal.
What I was talking about
Everything
is that
proceeding smoothly for Cygnus.
Nominal.
The first stage gives quite a lot of delta V
Avionics
to
power
the
is nominal.
second stage. Because it was at 4 kilometers at separation. And
reaching 135 kilometers.
You compared this to the 1.2.
Attitude nominal.
Or the 2 point something. The Falcon 9 first stage gives.
Stage 2 TVC is nominal.
Stage, so. If this second stage would be liquid, it will be
power
quite a big
subsystems
rocket.
remain nominal.
Not that I'm saying that it's shit.
Altitude has just reached 150 kilometers.
150. So it'll climb to
Stage 2 continuing to propel Cygnus now at 1,100 miles per hour.
Power and TVC systems remain nominal. Attitude nominal.
Looking at it, it is.
We are nearing 1 minute to stage 2 burnout.
Come on. Apogee is 200 kilometers.
TVC is nominal.
It will start pitching down right now to actually
Attitude
raise
nominal.
that apoapsis.
Altitude 180 kilometers.
KSP players will know why, but
power subsystem nominal.
Because it has hit the required apoapsis, it is calculating the
Stage 2 burnout coming up in about 30 seconds. Cygnus velocity currently over 15,000 miles per hour.
Come on. It's going to be very close to making orbit, but that's
attitude remains nominal.
That's why I think the dangers
altitude
of solid rockets.
Reaching 190 kilometers.
Second stages. Look at this. Oh, that's overshot massively. Hold on.
Stage 2 burnout.
Whoa. That's
FPS disabled.
Another bit of performance they can use. I believe they aim for 220 by 200.
Attitude nominal.
Stage 2 burnout confirmed. Cygnus moving at over 16,833 miles per hour.
Active.
Wait for separation.
The next milestone will be Cygnus separation at about 8 minutes and 49 seconds after launch.
Power is nominal. Antares will coast for roughly another minute prior to payload separation.
But yeah, this is what I talked about. The solid rocket booster as a second stage is a good idea, as in it's really reliable.
Systems continue to perform nominal.
But then on the other hand, performance-wise,
altitude 190 kilometers.
Meh. And looking at this, you can't shut it down, so you need to
apogee and perigee within 1 sigma,
lot, which makes you lose a lot of velocity and performance, because if they would just burn straight,
roughly 30 seconds to spacecraft separation,
or just point like 0 degrees
power is nominal.
Pitched, it would probably get you a lot further than what it did right now. But yeah.
spacecraft separation.
Team celebrating the confirmation of the spacecraft separation. Cygnus is now flying on its own.
Maneuver initiated.
Yay.
LC, that will end our callouts here for the NG-12 mission for Antares.
Excellent job, Ace. Excellent job. Good launch all the way around. Let's go ahead and continue with our post-launch checklist on countdown 1. And prop 1, step 423. Can you give me status on pulse purging?
So yeah, they're right now pacifying the second stage.
LC is prop 1. Pulse purging is complete.
Okay, copy that. And site control, step 424, remove aft AGN2 flow and reconfigure ECS for post-launch.
Where's it going?
Copy
the
that
second
and work.
stage, or
Copy and work.
what?
Core 1, LC, countdown 1.
I might have missed this, what I said.
LC Core 1 on countdown 1.
Yeah, Core 1, you can direct Yuzhnoy to power off their MS ground equipment and report when complete. Same with their FMS as well.
Copy that, LC. They have to wait till they get access to the island to do that.
Oh, okay. Understood.
But I will let them know they're allowed to proceed once they gain access.
Roger that. And Ops 1, step 427, you can deactivate arm enable and verify.
LC Ops 1, arm enable rotated, arm enable indication no longer illuminated, and I can give you the 428, Ops 1, launch enable removed.
Copy that. And GSO, disable your local launch enable button.
It
enable
overshot by quite a large amount if they were.
Copy that, GSO. We'll check 429.
Overshot by 40 kilometers.
LC, this is site control. Step 424 is complete.
Roger that. Site control 424 is complete.
We'll see what they have to say.
And Ops 2, if you can record your ground mock volts and currents.
But yeah.
Ground mock, external power on and green, and power supply voltage is 27.96. Power supply current 0.6.
I need to go and fix
Copy
my
all
3D
there,
printer.
Ops 2, and can you remove ground mock
I broke it. Dumb me.
Ground mock external power off.
Roger that, Ops 2.
So yeah. Thank you for watching. Yeah, well, I'll try and make something from the rocket project I'm doing right now. Okay, well, I turned it off anyway, so who cares? But yeah, I will probably make a video about what I am doing with my rocket engine right now, because I need to document that anyway, so yeah, will be cool to show you what I'm doing, and yeah, but for that I need to fix my 3D printer, because I need to print a part which is going to be featured in the video, but yeah, I can't print, well, because I broke my 3D printer, yeah, well, I got a new nozzle because the okay, I'm gonna tiny bit what I'm doing. Simon probably knows, but yeah, what I'm doing is PLA. Yeah, I'm making a hybrid motor, but yeah, progress. Well, not really a lot of progress, but yeah. What I'm doing is 3D printing it with PLA that has metal, copper in this case, in it, and then melting away the copper, or melting away the PLA, or actually evaporating away the PLA, and then leaving the copper. Copper is going to be heated up to 900 and something degrees, melted together, solid metal parts. That's what the project is about, and so I'm going to first test that on school in the oven they have. It goes to around 1,000 degrees, so yeah, that will be alright. And then with that, we're gonna see if this process actually works. Before that, more not okay. I'm gonna stop because I need to make a video about it. And then which is gonna be unscripted though. So yeah, it's a pottery. Yeah, it's a pottery kiln. Yeah, it goes to around, but they're still working with clay in it, so yeah, we can't use it till Friday, so yeah. And they're gonna turn it on Friday, put our part in, then leave it over the weekend, take it out on Monday and give it back to us, or we're gonna get it. Yeah. Then see what happened with it, if it actually works. And that's part of the process. But I broke my 3D printer because to print the metal filament, you need a hardened steel nozzle, otherwise it will wear out your nozzle and it will just mess up the prints and not look good. But yeah, I tried to switch out my my nozzle, but then so basically the hot part of your 3D printer has like a threaded. Yeah, it's a threaded metal tube with, I believe it's nylon on the inside to isolate the filament. When it's going down to, you have a sort of block which gets heated up with the nozzle underneath. But then again, I was trying to unscrew the nozzle, which in turn gave some torque to that part, which can't turn this way anymore because it's completely screwed in. So what I did, I literally broke off the whole thing. So yeah, smart me working. But yeah, right now you could probably hear the doorbell ring. That is my replacement part. So yeah, I'm gonna fix it, and I hopefully make a thingy. But repair it. You'll see it on Twitter. But yeah, yeah, it's kind of sad, but yeah, I don't mind. I just got it repaired, so yeah. Printing some parts for my 3D printer again before I am continuing with printing. So yeah, I already printed out a Formula 1 car. If you're watching this later, if you want me to make a video about that, like, please let me know, because I don't know if I'm gonna put it on my main channel. Maybe I need to make a second channel for all my Formula 1 stuff, because I saw people disliking my Formula 1 test drives. I don't know if it was because of my bad driving or because of like the content. So yeah. But on the other hand, well, this is what I like to do, and if they don't like it, they should bugger off and leave me alone, leave me to it. But yeah, next week, you might have noticed the lack of content on my channel lately. I only did like the launch almost 2 months ago, and since then I haven't done anything. Well, short story, I'm really busy with school and all the project that needs to be finished. The rocket project, I am going to try and record the static fire of the whole rocket engine, record the whole project. We're gonna give a presentation at the end. I will see if I can get that recorded. It's gonna be in Dutch, but I will try and do a version in English if I can. So, or just the Dutch presentation with English subtitles, or both. And yeah, that has to be done in December. So it's again rocketry, but doing the extra video stuff on it doesn't end well. I'm still writing scripts for the Rocket Talk videos, so those haven't died yet. They just are on really low heat at the moment because school's more important. Subtitles is fine. Yeah, okay. Cool. Yeah, I think that's an update. I really want to make this content again because I saw my channel is still doing quite okay for being this small, but yeah, just I don't really have the time. Maybe I'll do some sort of KSP streams again or something like that, which I find quite fun. I was actually constructing the ISS, but then I found new mods, so I'll probably do it again. Sometimes, maybe somewhere next week. If I have the time, yeah. Fun stuff. And again, to be honest, I've been really busy last month with my 3D printer because I quite like it, and next to rocketry, Formula 1 is my passion, so Formula 1 is quite cool, and I made a car, and I'm also working in CAD to practice working with CAD software to design parts for which are going to be useful for the rocket project, but then again, probably the rocket parts. So I needed more practice with this. So what I did is I redesigned the rear wing and the front wing, put that through some sort of virtual wind tunnel, and it looks promising. But then my 3D printer broke, so yeah, I need to fix that. Yeah, so follow me on Twitter for all those updates, and hopefully tomorrow somewhere. No, and I haven't printed the reusable launch vehicle technology demonstrator wings yet. I still need to make a sort of bracket part to keep the wings. Like, what I did is basically made 3 slots from the wings, and those have screw holes in them. But then I need to make a separate part that goes onto the main body that holds them in place, and I probably will need a bottom bracket to keep it in place. But I'm still I want them to be as close to final parts as possible, so I don't waste a lot of filament printing them. But yeah, I'm still not really keen on what I've drawn, so yeah. I don't want to. It is like 90% ish finished, and then again, if I print it and the elevators don't work, I will need to go back to the drawing board and try again. But yeah, currently that doesn't really have priority over everything else, so yeah. But yeah, thank you for standing by. Everybody just keeps watching me ramble. I think it's funny. Anyway, if you found this stream and later on anyway, and you like this, please consider subscribing. I do this almost every time a rocket launches, so yeah. And I'll do KSP shortly, within the next week, 2 weeks, because let's see, 2019 in space. I'm messing this up. Let's see, 2019 in spaceflight. 2019. Next launch is probably. It's gonna be in a week, 2 weeks. Oh God, another launch withdrawal. Oh, another Ariane 5. I like the Ariane 5. It's the European rocket. Parts are made in the area where I live, so that's why I like it. Depending on the times though, because let me pull up the calendar. So real Donglish for you there. CST 100 paddleboard. Yeah, but I can't stream that. I can't host that because probably it will be during school time, right? Or is it in the evening? If so, I can stream it, but otherwise not. I haven't checked it. I thought it was like during school time for me, but I could be wrong. Ooh, December is gonna be really busy though. Ooh, is there anything scheduled on my birthday? Ah, not yet. Afternoon CT. Okay, I'll probably host that. So yeah, everybody, this is it. If I have any more updates, I will probably let you know next stream. So if you like it, watch out for my KSP streams. They will be quite fun most of the times. Yeah, see you in the next one. Thank you for watching. This is me out. Bye.